Now that we have gotten good with what a logarithm is and how to use logarithms, we're now ready to solve the problem that we started with at the beginning of this chapter. At the beginning of this chapter, we found that we were able to solve problems with the variable in the exponent by getting a common base on both sides. And if they both had a common base, we could set the exponents equal. So then the logical question from there is, what if I can't get a common base? What if I can't get the same base on both sides? How do I solve that problem? And as you might imagine, this is more often the case than not. So to set this up, we had to talk about logs yesterday, and today we're finally ready to answer that question. And first I want to talk a bit about these things called natural and common logs. Natural logs and common logs. The first one is the common log, and that is a log with a base of 10. We use these a lot in science, especially with scientific notation. Scientific notation is always times 10 to some power. So base 10 is a pretty common base. And so to save us some work, this base is going to be unwritten. In other words, if we've got, let's say, 10 to the third power equals 1,000. And we wanted to write this in a log form. We would write this as log base 10, which we would not write, of 1,000 is equal to 3. So whenever we do not see a base written, we will always assume it's a base 10. And in fact, whenever we have a base 10, we won't write it. So we are now ready to solve problems like 10 to some power equals maybe 18. If I were to change this to a logarithm, I wouldn't write the base. I would just write log, because it implies a base 10 of 18 equals x. And what's nice about log 18 equals x is I can do log 18 on my calculator. What I'll notice on my calculator is there is a log button right next to the 7. No base is written. So that assumes the base is 10. So we can type in log 18 and close the parentheses. And when we hit enter, we find out the value for that. Our value for x is 1.255. 1.255. And we rounded down, so it's going to be a little bit less than we wanted. But if we wanted to check that answer, 10 to the x, 10 to the 2, because that equals x, 10 to the 1.255 power on our calculator, 10 raised to the 1.255 power. Just got an extra 1 in there. So 10 to the 1.255 power. Hit enter. And it's 17.98. If you round that up, it's 18. And because we rounded our exponent down, we ended up rounding down the answer. But it's essentially, if we round it just to the tenths place even, 18.0. So that's our first natural log, a base 10. It is unwritten. I'm sorry, that's our common log. The natural log is a different base. The natural log is a base, what we're going to call E. And E stands for Euler's constant. Euler is spelled E-U-L-E-R. Euler. You don't need to know that, though. And E is kind of like pi in that we use it to estimate a number that has no pattern, no repetition. E is approximately 2.718, and it goes on and on and on forever with no pattern. It is going to be written as Ln, standing for log natural. In Italian, the nouns and the verbs and the adjectives are in a different order than English, so the L comes first. Log natural, meaning natural log implies the base is E. And E is an interesting one because it kind of comes up naturally all over the place. It comes up in population growth of bacteria. It comes up in decay and radioactive decay and carbon dating. It comes up in finances and how your bank account grows. It comes up in all these different natural places. And because it comes up so often, we do the abbreviation for it. So, for example, if we had E, let's do it in blue again. If we had E cubed, and if we were to figure out what E cubed was, we'd come up with about 20.08, 0.09 really, rounded. And we were to change this into a log, we would use a natural log of the 20.09 would equal the exponent of 3. So no base written. Natural log implies the base is E. And that allows us to solve problems like e to the x equals 35. Because we have to just change that to a log, and because the base is e, we'll write it's a natural log of 35 is equal to the x. And what you may have noticed on your calculator is right next to the number 4, underneath the log base 10 is the natural log button. So we can do a natural log of 35 and find out our x is 3.56. Well, 55. Let's go 555. So x is equal to 3.555. And again, if we were to test this in our calculator to make sure it's right, e to the 3.555, again, we rounded down, so we're going to end up a bit too small. The way we get the e is we hit second, and then above the ln, you see it says e to the x, and type in the 3.555, an extra 3 again, 3.555, should be just shy of 35, and indeed if we rounded the 10th place it would be 35.0. So we can take a base 10 or a base e and type those into our calculators. We are going to use base e more often, the natural log, unless it's convenient to go with a base 10 because it's going to be more useful to us when we get to calculus. So let's try a few examples where we're going to solve these problems that have the wrong bases. And the way we solve them is we are going to take the log, preferably the natural log, of both sides. So for example, if we want to know 5 to what power equals 9, we're going to take a natural log of both sides, ln, ln. So we have the natural log of 5 to the x equals the natural log of 9. And what's nice about this is we know that this exponent inside the log can move out front. So we have x ln of 5 equals the ln of 9. We want to solve for x. We want to get that x alone. It's x times the natural log of 5, so we'll divide both sides by the natural log of 5. And x is equal to whatever the natural log of 9 is, divided by the natural log of 5. And our calculators can help fill in the blank from there. Natural log of 9. Make sure you close the parentheses after your natural log. Very important step. Divide by natural log of 5. For some reason I'm hitting the button twice. There we go. Natural log of 9 divided by natural log of 5 is 1.365. 1.365. And if we were to check it, 5 to the 1.365 power is approximately equal to 9. Now we can start to make these problems a little more interesting, a little more exciting, by saying something like 3 to to the 2x minus 4 equals 6. And again, anytime we want to get an exponent out, a variable out of the exponent, we'll take the natural log of both sides, because we can do anything to both sides of an equation. When we do, we have the natural log of 3 to the 2x minus 4 equals the natural log of 6. Now our exponent that's inside the log can come out front. We want to make sure that entire exponent comes out front, so we have to put it in parentheses as we do so. 2x minus 4 times the natural log of 3 equals the natural log of 6. Several ways we can solve from here. I'm going to go ahead and just distribute the natural log. So that's going to give us 2x natural log of 3 minus 4 natural log of 3 equals the natural log of 6. Thinking back to Unit 1 when we were solving our formulas for a variable, we're solving for x. We want to get everything without an x on the other side. So we'll add 4 natural log of 3 to both sides. 2x natural log of 3 equals the natural log of 6 plus 4 natural log of 3. Almost done. To get x alone, we divide by everything it's multiplied by. Divide by 2 natural log of 3 on both sides. The natural log of 3 and the 2's go away. So x is equal to the natural log of 6 plus 4 natural log of 3 over 2 natural log of 3. And our calculator can do all the work from here. As long as we're careful. First thing we need to be careful of is every time we hit the natural log button, it's going to open up parentheses. Automatically. Make sure you close the parentheses every time. Another thing to be aware of is to make sure the computer or the calculator knows that it's a fraction. Put the entire numerator and the entire denominator in parentheses. So parentheses for the numerator, natural log of 6, close the parentheses, plus 4 natural log of 3, close the parentheses, and then close the parentheses again for the numerator. Divided by, open a parentheses for the denominator, 2 natural log of 3, close the parentheses on the natural log, close the parentheses on the denominator, and our x, our solution, is 2.815. 2.815. Let's try another example. Number 3, we're going to do 7 to the x equals 9 to the x. What exponent gives the same answer for both a base of 7 and a base of 9? Well, to get the variable out of the exponent, we'll take a natural log of both sides. Natural log of 7 to the x equals natural log of 9 to the x. And what's nice here is this grabs those exponents and moves them in front of their logarithm. So we have x natural log of 7 equals x natural log of 9. Thinking back to when we solved our linear equations, we need to get all the variables on the same side. So let's subtract x natural log of 9 from both sides. When we do, we get x natural log of 7 minus x natural log of 9 equals, anything minus itself is always 0. And then we know once we have all the x's on one side, we can factor out that x, leaving behind natural log of 7 minus natural log of 9 equals 0. It's x times that stuff. So to figure out what x equals, we divide by that factor of natural log of 7 minus natural log of 9. And this one's really nice because it just leaves x on the left, and 0 divided by anything is 0, so x equals 0. And sure enough, if you think about this, we probably should have known this at the beginning. 7 to the 0 is equal to 9 to the 0, because anything to the 0 power is always 1. But it was a real nice exercise to go through all that step to set up our last example. These make great test type problems. 3 to the 2x plus 4 equals 5 to the x minus 6. Again, we want to get the variable out of the exponent. We cannot get the same base on both sides. So we'll solve by taking the natural log of both sides. Gives us the natural log of 3 to the 2x plus 4 equals the natural log of 5 to the x minus 6. Once we see an exponent inside of a logarithm, our first instinct should always be to move it out front of the log. In parentheses, as signifying the entire exponent's been moved out together, 2x plus 4 times the natural log of 3 equals x minus 6 times the natural log of 5. We have fewer options for solving here. We need to get rid of these parentheses. So let's distribute through the parentheses just like we did last time, giving us 2x natural log of 3 plus 4 natural log of 3 equals x natural log of 5 minus 6 natural log of 5. Now we're just solving a linear equation. We need to get the variables all on one side and everything without a variable on the other side. So let's move the variables to the left. We'll subtract x natural log of 5 from both sides. Then the 4 natural log of 3 has no variables, so we'll subtract it out as well. Subtract 4 natural log of 3. So we have 2x natural log of 3 minus x natural log of 5 equals negative 6 natural log of 5 minus 4 natural log of 3. Since we have the x's all alone on one side, we can now factor it out, leaving behind 2 natural log of 3 minus the natural log of 5, still equal to negative 6 natural log of 5 minus 4 natural log of 3. Finally, to get the x alone, we divide by what it's multiplied by. Divide by 2 natural log of 3 minus the natural log of 5 on both sides. And that leaves behind just our x is equal to negative 6 natural log of 5 minus 4 natural log of 3 over 2 natural log of 3 minus natural log of 5. And while it got ugly, the process was very simple pattern that we saw in Unit 1. Get all the variables on one side, factor out the x, and divide. Now when we type it in our calculator, we're going to have to be careful. First, the numerator and denominator must go in parentheses, so the calculator knows there's more than one piece to the fraction. Also remember, every time we hit the natural log button, it's going to automatically open up a parentheses. Make sure you close all 4 of those parentheses. So a parentheses for the numerator, negative 6 natural log of 5. Actually, I'm hitting double keys for some reason. Parentheses for the numerator, negative 6 natural log of 5. Close the parentheses on the natural log, minus 4 natural log of 3. Close the parentheses for the log, close the parentheses for the numerator. Divide. Open parentheses for the denominator, 2 natural log of 3. Close the log, minus the natural log of 5. Close the log, close the denominator. And enter. Our solution for x is going to be negative 23.905. negative 23.905. And we have our solution. A very short video today because really all these problems solve with the same general pattern. We just want to get used to taking the natural log of both sides in order to find our solution. So take a look at the homework, practice, 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 and come to class with questions. We will see you then.